So we're going to look now at a linked entities example that will demonstrate how we can avoid returning more rows and columns than we need to, and avoid running more queries than we need to. If, for example, I run this very simple query, find all the albums where the album title contains the phrase greatest hits, then we can see from the SQL generated that a where clause has been added, and so we'll only get back the albums that match our query. And if we decide we want a maximum of 5 results, we can chain a take5 method onto our link pipeline. And again, when we run this and look at the generated SQL, we can see that the SQL itself is using a top clause to limit the number of rows returned to 5. And I could put an order by in here too, to order our results by artist name. And then, yet again, the database is doing all the hard work for us with an inner join and an order by clause being added to the SQL statement. So it looks like we hardly need to worry at all. The SQL that's being generated seems completely reasonable. But let's suppose I insert a toList into this pipeline, straight after albums. Suddenly, things go very wrong. First of all, we actually get no results at all. Now, why is that? Well, linked entities interprets the string.contains as being case insensitive, while linked to objects is doing a case sensitive comparison. So let's fix that first of all with a slightly hacky fix of converting the title to lowercase before the comparison, and let's try again. Okay, now we've got the same results as before, but when we look at the generated SQL, it turns out that we're requesting all the rows from the albums table. We're literally pulling the whole table down. And then, in order to do the order by, we're performing another SQL query for every single individual artist. And this is a performance anti-pattern, sometimes known as select n+1. And it refers to whenever you're performing a query that returns n rows, which could be fulfilled with just a single SQL statement, but actually results in n+1 SQL queries being executed. But why did this happen? What did toList do that broke our query? Well, it moved us from the world of iQueryable to IEnumerable by evaluating the query at that point and caching the results in memory. And if we take this toList call out and hover over each method in our link pipeline, we can see that these aren't actually the IEnumerable versions of the link extension methods, but special versions that take an expression and return an iQueryable. Now, in this course, we're not going to do a deep dive into the details of expressions and iQueryable. And there are other Pluralsight courses that will cover those topics in depth if you want to explore them more. But the important thing to recognise here is that the magic of linked entities is achieved by analysing each lambda expression that you pass into the various link extension methods and turning those into equivalent SQL statements. And that's why sometimes you'll find that your linked to entities queries fail because something in the lambda expressions can't be converted into SQL. So say, for example, we tried to handle the case sensitivity problem like this instead, using the indexOf method with the string comparison.currentCultureIgnoreCase option set. Now this would work absolutely fine with linked objects, but will fail with a not supported exception whenever we try to run it with linked entities, because the link provider doesn't know how to turn this into SQL. So the important thing to remember is to stay in the world of iQueryable as long as possible and avoid executing your query until you finish constructing the whole thing. Otherwise, you'll end up pulling down lots more data than you need to. And you can also end up needing to run more queries than you need to. Let's take a look now at another example where we'll see how it's possible to accidentally create a select n+1 problem.